Okay, as we look at this problem, I saw several groups having discussions about it because people weren't really sure where to start. So when you're not sure, just take a few minutes and write down everything you know. So I went and looked up the K sub F and the K sub B for water, so I'd have those handy. And I wrote down my equation. Delta T is K sub F times the molality. Actually, that should be K sub B. K sub B, not K sub F. So now delta T divided by K sub B is equal to M. So we take the desired change in temperature, 1 degree Celsius, divide by K sub B, and that tells us we have 2.0 molal. That means 2.0 moles per kilogram of water. 1 kilogram of water is 1,000 grams of water. I changed that right away because I knew that I had 100 grams of water in my sample. So now I have kilograms of water and grams of water canceled. Now I can change the moles into grams and we get 12 grams of ethylene glycol. So that's a fairly typical problem that you might see for boiling point. Now, we've already discussed the freezing point depression, which is the related concept. And in lab, you actually went through and did a molar mass calculation. So now we're going to look at two of the harder problems. At this point in time, these aren't going to seem particularly difficult because we just did a couple of problems like this and we're talking about boiling point elevation and freezing point depression. When these problems seem hard is when you are looking at a white sheet of paper with a bunch of problems on it and there's no indicators of what they're about. That's when they seem really challenging, and these are multiple concept problems. So when we look at the first one, 1.25 grams of oil is dissolved in 100 grams of benzene. The boiling point of the solution is 80.31 degrees Celsius. What's the molecular weight or molar mass of the oil? So what's the first thing that it would be logical to do in this situation? Write down what you know or what you can go look up. So what do I want to look up? I know that I have benzene, so I want to look up the K value for benzene and the normal boiling point for benzene. So the normal boiling point for benzene is 80.20 degrees Celsius, and the K sub B is 2.53 degrees C per molal. On a quiz or test, you would either have this information provided in the problem or there would be a chart attached to the back of your quiz or test. I often like to put the chart on the back because when it's included in the problem, that gives you a clue of what you're supposed to do. And so by putting it on the back, that tells me, do they really understand the concept that they know to go look this up? So a lot of times you'll see it on the back. So now we write down the equation. Delta T is equal to K sub B times M. I know K sub B. I don't know the molality because I don't know the molar mass of the oil. I know grams per 100 grams of benzene. So I'm going to start by calculating delta T by subtraction. So delta T is equal to my boiling point, 80.31 degrees Celsius, minus my normal boiling point, 80.20 degrees Celsius. And so I get 0.11 degrees Celsius is my delta T. So now we can go through this. Now, when I actually worked this problem, I had just 80.2, so I only worked it with one significant figure. But then I decided we should change that and keep 2, because in the next problem, if you keep it as 80.2, you end up with no significant digits and no change. So we're going to work it this way. So now we know that delta T divided by K sub B is equal to the molality. like you to grab your calculators so we can get a second significant figure here. So my delta T, 0.11 degrees Celsius, divided by 2.53 degrees C per molal. What do you get for that? With 1 sig fig, it's 0.0443. So now we can use the molality to find the number of moles. I already know the number of grams. So I know that I have 0.043 moles of oil per kilogram of benzene. And I know that I have 100 grams. So 1 kilogram is 1,000 grams of benzene. And I have 100 grams of benzene. So I have 0.0043 moles of oil. Now again, I have the moles, but I'm not done. I'm trying to find the molar mass, or the molecular weight. So I know that usually has units of grams per mole. So 1.25 grams divided by 0.0043 moles. And again, I only kept 1 sig fig when I worked this out. It's something around 300. What does it actually come out to be? 290 grams per mole. So this is similar to what you did in lab with the freezing point depression. It's similar to a couple of the problems we worked last week in class. Now let's look at the next one. The next one, azulene has an empirical formula, C5H4. When 0.640 grams of this was dissolved in 100 grams of benzene, the solution boiled at 80.23 degrees C. What's the molecular formula? Now, molecular formula is something that was introduced in Chem 111. We talked about empirical formulas and molecular formulas. How did we convert empirical formulas to molecular formulas in Chem 111? What did we have to do? Do you remember? I hope. Moles of each? Like the molar mass of each. So remember, you had the empirical formula and you had the molar mass, and you calculated the empirical mass, and then dividing molar mass by empirical mass would give you an integer, hopefully. And then you would multiply the empirical formula by that. Okay, so that's the concept you need to remember to do the last part of this problem. So go ahead in your work groups now and do this one at your spots on the board. And again, you're going to have to spend some time talking through this.